In this video, I'm going to solve the question 12 trial. It's a truss, but at the moment we're just finding the reactions. And the first thing we want to look at is when we find the reactions, this is a relatively hard question to find. So what we know is that this roller, the left reaction, we know that that's going to be 45 degrees up. We've been given the one force, which is 100 kilonewtons in this downward direction. So the question is, how do you solve this without using the three-force method? Because a lot of students don't like to use the three-force method. Well, there's a couple of ways we could approach it. Here's how I would start. What I would do is I would find the perpendicular distances of things. I would say that if we know this distance here is 3 meters, that distance there is 3 meters. So what we can do is we can find this distance here. We can find what is this distance here, which is the perpendicular distance. Now I've labelled that n. Now what is this perpendicular distance here? And then I also need to find, I'm going to use red for this one, the reaction, the perpendicular distance of reaction. So for me, this is the intuitive way. Whoops, that's not quite sticky enough. Okay. So I maybe haven't drawn this quite at the right angle. I don't care enough to fix it. It'll do. And I've labelled this distance here S. Okay, so first of all, what I need to do is I need to find, well, what is this perpendicular distance N? If I've been told that this here is 3, this value here is 60. So vertically opposite angles are going to be 60. So what is the value of n? Okay, well, if we look at, that's a 30-60 triangle, and we know that with any 30-60 triangle, if this is 100, then this small, if the hypotenuse is 100, the smaller side is going to be 50. You should be very familiar with that by now. That means this side here is going to be 86.6% of that. So if this is 3, then n is going to equal 3. Is this adjacent or opposite to 30 degrees? Let's use the 60, right? We're going to say it's opposite 60, so we're going to say it's 3 sine 60, which is the same as saying 3 times 0.866, which equals some value for n. I can't do that in my head, so I need to get the calculator out. Okay, for S, what is my distance? Well, what's the total distance of this diagram here? So we're finding, effectively, this is what we're finding here. 45-degree triangle. What is this value of S? We're told that the entire length of this thing is 3 triangles wide. So if it's 3 triangles wide, it's going to be 9 meters. So if it's 9 meters, well, for all of our 45-degree triangles, we know if this is 9, or if this is 100 rather, if that's 100, this will be 70.7 on both sides. Or another way of saying it is, we know the angle, this is the opposite side. We're going to say that this side here, S, equals 9 sine 45, which is equal to 9 brackets 0.707, which is equal to, S is equal to 9 times 0.707 equals, oh, I didn't type that in properly. 9 times 0.707 equals, okay, once I have these distances, the question actually becomes quite easy to solve. So let's go through it this way. What we're going to say, I'm going to use this space here. This should be sufficient space. So what I'm going to say is the sum we're taking clockwise as positive, we're taking the sum of any moment equals 0, but we're going to be taking all of our measurements. Do we want to find R? Let's say we want to find R for our example. If we want to take R, then we're going to measure everything from point L. Right? By doing so, we're going to multiply, we're going to say 0 equals RL times 0, which is 0, so that gets ignored. You don't really need to write that, but I do. And then what we're going to have is two other forces. We're going to have, we've taken all of our moments relative to, we've taken all of our distances relative to point R. So I'm going to have to keep it as R. Whoops. No edits. Okay. We're saying we're going to worry about R later. What we're going to say is for the moment, R is going to multiply by 0. Ignore that for the moment. We're going to take this force here, which is 100. Okay, is it going clockwise or anti-clockwise relative to this point? Relative to R, is it going clockwise or anti-clockwise? Positive. So it's going to be 100 times the distance, which is n. And then this one here is going anti-clockwise. Let me show you anti-clockwise. So it's going to be minus RL times S. I've just called them those distances. So let's rewrite that as, we know that 100 times this number. So 100 times n is going to be 2, alright, this is 0. 0 equals 259 minus 6.36 L. Therefore, if we move this over to the other side, it changes sign. We're going to add that to both sides. So we're going to say that 6.36 L equals 259. Therefore, RL is going to equal 259 divided by 6.36, which 259 divided by 6.36 equals 40.72 kilonewtons at 45 degrees. Okay, I'm going to leave this here. I will put up the full working out for this method later. If you don't want to use these perpendicular distances, it becomes very difficult because you don't have a sum of the forces vertically very easily. You kind of have to convert everything. You have to convert the RL into a horizontal RLV and RLH, splitting them 50-50 because we know that it's that side. But it becomes very complicated. I have got that worked out here. I'll post this as a photo, but the point is it's a lot of working if you want to solve it using that method, and I wouldn't recommend it.